We're going to look at an example now of using static friction and kinetic friction. And to do that, we're going to look at a box, and this box has an applied force on it. It has the force due to gravity. It'll also have the normal force, and it'll have the force of friction, either static friction or kinetic friction, in this direction, depending on the magnitude of the applied force. Now, this is a mystery box. Depending on the edition of the book, I don't know if this comes up in the hardcover copy, and it doesn't in the e-copy, but I know that in my edition, which is an edition earlier than this, as well as in the calculus-based edition, they refer to this box as a mystery box, and it has question marks all over it, and the word surprise, because you don't know what's in it. And then, oh, why?
Just like last time, it's being pulled and pushed in too many directions.
Yeah, pulled and pushed too many directions, yeah. The Newton's action, reaction, all that going on.
Newton's law of overreaction.
And so I don't know why they took away the mystery component, but then again, in the other edition, they never did tell us what was in it, which kind of seemed to be a bit of a letdown. So let's take a look at a problem involving this mystery box that no longer says mystery but should. But it says mystery here, so I don't know. Okay, so our 10 kilogram mystery box rests on a horizontal floor. The coefficient of static friction is mu s equals 0.40, and the coefficient of kinetic friction is mu k equals 0.30. Determine the force of friction, Fr, acting on the box, if the horizontal external applied force, Fa, exerted on it is of magnitude, and then we have 5 choices. We're probably not going to do all 5, but here's our problem. That wasn't supposed to happen.
It's a shame that you recorded that.
Yeah, well, you know. I gave up a long time ago having my recordings be perfect. Okay, so let's take a look at our mystery box to remind ourselves I don't know how to place this. Let's see. There we go. Okay, alright. Now I guess maybe I just want to select, is that a pen? No, it's a brush. I'll select, okay, there we go. Okay, so let's remind ourselves of our mystery box. Here's our box.
And
and
actually not on an incline.
it's not, no. There we go. There's our box. Okay. Color. No, it should have question marks.
Yeah, the question marks.
Yeah.
There's that inner turmoil.
Yeah. Where's the eraser? There we go. Let's
Maybe we should leave it.
I think we should do a better job.
Oh, look, now you're blurring the screen.
This is just all going downhill.
Why don't you just use the pen at the top of the screen?
Because she's a free spirit, you don't own her.
That's right. Oh, because I actually want to use the brush because it ends up being darker, which makes a better recording. Okay, so here's our box. Question mark. Mystery. Okay, and we have the force of gravity down. We have a normal force up. Now, we suspect that the normal force is equal to the force of gravity because we've talked about that, but we haven't actually shown it yet on this particular problem. And then we have an applied force, which we often indicate with Fa. And then we're going to have the force of friction, and I'll just call it Fr. A lot of times I'll put Fk for kinetic friction, but this time we don't know for sure if it's kinetic friction, so we'll just wait on that. Okay, so part A is easy. Part A says, what if we have a magnitude of 0 newtons? So if we have a magnitude of 0 newtons, first of all, is the friction static friction or kinetic friction? Static. And how much is it? 0, because if it were more than 0 and my applied force were 0 and my static friction were more than 0, then it would be pushing the box in this direction, which means you just set the box on the table and zoom, it goes off. Okay, so for A, we're just going to say the force of friction is 0 newtons. Okay, B. Now, anytime you have a friction problem, somewhere you need to write that F, if it's kinetic friction, Fk equals mu k times the normal force. If it's static friction, you write Fs is less.
What just happened? Huh?
Of course, whenever you're recording this
Oh, of
now,
course.
Did everything go wrong?
is it still recording or did the computer just mess up?
It's
the projector.
probably still recording. This is the projector. So our projector, for those of you at home, is
On the frets.
on the fritz, and I don't know why. It's saying no signal. Okay. There we go. Okay.
Yeah, yay.
All right.
Just as I stand up performance.
So Fs is less than or equal to mu s times the normal force. So we don't know which one it is. If you have enough of a force that you can overcome the static force, then you have frictional force. If you don't, then you have static friction. If you have enough of a force to overcome the static friction, you have kinetic friction. Otherwise, you have static friction. So let's remember that our vertical and horizontal are completely separate. So we'll look at our vertical first. Okay, our vertical. What forces do we have?
We have gravity.
Gravity. And do we know what that is? Our mystery box, we know, is 10 kilograms.
Well, do we know if it's on Earth or not?
Oh,
'Cause it could be a really mystery box.
yeah, let's assume it's on Earth.
Alright.
Okay. So then what is the force due to gravity?
MG.
mg,
98 newtons.
yeah, which here would be 10 times 9.8 or 98 newtons. Okay, let's say we don't know what our normal force is yet, but we do know by Newton's second law that our net force equals, and we'll call up positive, so it'll be Fn minus Fg. Net force is mass times acceleration equals, I sometimes use N for the normal force, so you'll just have to, play along with me. Fn equal minus 98 newtons. Is our box accelerating up or down?
No.
No, so this side is 0 equals Fn minus 98 newtons, or therefore Fn equals 98 newtons. Okay, so now we know that. So we have to decide first, do we have a big enough force to overcome static friction? So let's look at mu s times n. So our coefficient of static friction is 0.4. Our normal force was 98. And so we get 39.2. And so the maximum static friction can be is 39.2. So that's static friction max. We're applying a force of 10 newtons. So are we applying enough to overcome the static friction? No. So how much static friction do we actually have? 10 newtons. Because if we look at our horizontal force, we have force applied, which is 10 newtons. We have the static friction, which we can say is unknown. We know F net we'll call to the right positive, is 10 minus Fs. We just said we did not have enough force to overcome the static friction, so we're not accelerating. So 0 equals 10 minus Fs, or Fs has to equal 10. So that's the answer. That's the answer to part B.
Yay.
Everybody okay with that? Okay. What are you dinging about? Let's see if my problem is still there. It is. Okay, so now let's look at part C. Now we don't have to do any more work for part C. Why not?
Because we still know what the static friction is.
Yeah, well, we know the
Well,
maximum,
max
the max static friction. So in part C, what can we say the static friction is? 20 newtons. Okay, part D, we have 38 newtons. Let's go back and look at our number here, 39.2. Okay, so part D.
Same thing.
Same thing. All right, so it turned out this one was easy enough to do all 5 parts. Okay, so now let's do part E. So now things change. So now, do we have enough force to overcome the static friction?
Indeed.
Indeed we do. So what kind of friction do we have?
Kinetic.
We have kinetic friction. And the kinetic friction equals, is not greater than or equal to, I mean, not less than or equal to, the, there I go, using N instead of Fn. The coefficient of kinetic friction times the normal force. Okay, we computed the normal force before as being 98. The coefficient of kinetic friction is 0.30 times 98. And what would we say the coefficient was? 0.30? So we get 29.4 newtons. Oh, look, I left off newtons here, minus a point. Okay, so this is our kinetic friction. Notice the kinetic friction is less. Yeah, is less than what the maximum static friction could be. All right.